Hello, in this short lecture I will give you a proof to the Pythagorean theorem. Actually, the Pythagorean theorem relates to a right triangle, like you see here in the picture, and it claims that right triangle that has one triangle that is 90 degrees. This triangle between sides A and B is 90 degrees. And the claim of the theorem is that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So c square equals to a square plus b square. In order to prove the theorem, actually we built a copy of this right triangle here. We built it by drawing on side B the side A. It is in the same line, and then actually we made line B that is perpendicular to line A, and the angle between side B and side A in the left triangle is actually 90 degrees. So the left triangle is a copy of the right triangle. We have here two triangles that have two sides that are equal to each other. Side A in the right triangle is equal to side A in the left triangle, and also side B in the right triangle is equal to side B in the left triangle. And actually the angle between side A and side B in the right triangle is 90 degrees because it is a right triangle, and also the angle between side B and side A in the left triangle is also 90 degrees. Therefore, we have here two triangles that are equal in two sides. We have two sides that are equal, and also the angle between two sides are also equal in these two triangles. It is actually 90 degrees in both triangles. Therefore, those triangles are coincides to each other. According to the rule that if you have two triangles that two of the sides of them are equal, and also the angle between those two sides are also equal in the two triangles, then we can say that these two triangles are coincides to each other. So in the left triangle is coincides, the right triangle is coincides to the left triangle. Now we can name the angle between side A and side C as alpha, and according to the rule that because of the fact that those two triangles coincides to each other, also the angles are coincide, so the angle between side A and side C in the left triangle also must be alpha. Okay, because of the fact that these two triangles coincides with each other, to each other. Now we know that in every triangle the sum of its angles equals to 180 degrees. So here in the right triangle, alpha plus 90 plus this triangle, this angle equals to 180 degrees. We can label this angle between side B and C as x. Okay, because we don't know what angle is it. So we know that x plus alpha plus 90 equals to 180 degrees. Okay, because of the fact that in every triangle the sum of its angles equals to 180 degrees. Now we can subtract 90 degrees from both sides of the equation, and then we will get that x plus alpha equals to 90 degrees. Okay, x plus alpha equals to 90 degrees. Therefore, x equals to 90 degrees minus alpha. Okay, as you can see here, x equals to 90 degrees minus alpha. So we can write here that this angle equals to 90 degrees minus alpha. We also know that in every line, every straight line, the sum of its angles equals to 180 degrees. So x plus 90 plus x plus x plus alpha plus angle that we don't know what angle it is, so we should label it as y. So we can say that x plus y plus alpha equals to 180 degrees. As you can see here, x plus y plus alpha equals to 180 degrees, because in every line the sum of every straight line, the sum of its angles equals to 180 degrees. But we know that x equals to 90 minus alpha, so we can write that 90 minus alpha plus y plus alpha equals to 180 degrees. Okay, x equals to 90 minus alpha. Now minus alpha plus alpha is equals to 0. So we have here 90 plus y equals to 180 degrees. And we will, no, it is plus y. 90 plus y equals to 190 degrees. We will subtract 90 from both sides of the equation, and we will get that y equals to 90 degrees. So, so the angle between side C in the right angle to side C in the left angle equals to 90 degrees. Okay, as you can see here, y equals to 90 degrees. As you can see in this picture, we have here a trapeze. This is a trapeze, and now we actually will calculate the area of the trapeze in two different ways, and then we will compare the results. Of course, they are equal to each other, and from this comparison we will get the Pythagorean theorem. So the first way to calculate the area of this trapeze is actually the area of a trapeze is equals to the sum of its parallel sides. That is to say, A is parallel to B, that therefore the area of the trapeze is A plus B times the height of the trapeze, and the height of this trapeze is A plus B, so it is A plus B times A plus B divided by 2. So the first way to calculate the area of the trapeze, we'll call it S, equals to the sum of its parallel sides, it is A plus B, times its height, that is also A plus B, divided by 2. Okay, as you can see here, the area of the trapeze is the sum of its parallel side, that is A plus B, times its height, that is also A plus B, divided by 2. So that is the first way to calculate the area of the trapeze. Now we will calculate the area of the trapeze in a second way. A second way to calculate the area of the trapeze is actually, we can say that the area of the trapeze is actually the area of its components, that is the area of the right triangle plus the area of the middle triangle plus the area of the left triangle. Okay, so the area of these three triangles equals to the area of the trapeze. So S equals to the area of the right triangle. The area of the right triangle equals to the base of the triangle times its height divided by 2. That is, the base is B, the height of the triangle is A, divided by 2, so it's B times A divided by 2, plus the area of the middle triangle. The area of the middle triangle is its base times its height divided by 2. Its base is C times its height, it's also C, and divided by 2. And the area of the left triangle is equal to its base times its height divided by 2. So its base is A times its height is B times B divided by 2. So the total area of the trapeze, as we calculated it in the second way, is the sum of the areas of the three triangles that the trapeze contains. The area of the right trapeze is B times A divided by 2. The area of the middle triangle is C times C divided by 2. And the area of the left triangle is A times B divided by 2. And actually, expression A equals to expression B because it is the same trapeze. So we can compare expression A to expression B. So we can say that A plus B times A plus B divided by 2 equals to BA or AB divided by 2 plus C squared divided by 2 plus AB divided by 2. Okay, we calculated the area of the trapeze in two ways, and then we compared the two results. They of course equal to each other. Now we'll multiply the two sides of the equation by 2. Then we actually will get that A plus B times A plus B equals to 2AB plus C squared. Okay, when we multiply the two sides of the equation by 2, we get here that A plus B times A plus B equals to AB plus AB. After we multiplied it by 2, it is AB plus AB, so it is 2AB plus C squared. Now we will open the brackets in the left side of the equation. A times A is A squared. A times B is AB. B times A is BA. And B times B is B squared. Equals to 2AB plus C squared. Okay, as you can see here, we opened these brackets and we get that A times A is A squared, A times B is AB, B times A is BA, and B times B is B squared. Here AB plus BA is 2AB. Okay. A squared plus 2AB plus B squared equals to 2AB plus C squared. So here it is A squared plus 2AB plus B squared equals to 2AB plus C squared. Here we can deduct from both sides of the equation the expression 2AB. So we will left it with A squared plus B squared equals to C squared. After we deduct from both sides of the equation the expression 2AB, we left with A squared plus B squared equals to C squared. And that is exactly the Pythagorean theorem that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. C square equals to A square plus B square. So in this way actually we proved the Pythagorean theorem. Okay, thank you very much.